For this lesson, we're going to start looking at transformations of quadratic functions. And remember, if you think back to our geometry lesson from last year, a transformation changes the position or the size of a function. And so we're going to look at a specific types of transformations, including translations, dilations, and reflections. And a translation moves our figure up and down or right or left. And for our purposes of this lesson, we're just going to be looking at up and down translations. The graph of g of x equals x squared plus c is the graph of f of x equals x squared translated vertically. So here we're looking at where we were going up or down. So let's take a look at some just pictures of what we're talking about when we talk about these vertical translations. So let's look at if c is greater than 0, the graph of x squared is translated the absolute value units of c up. So for example, if I had just a parabola that was at our axis, so we're looking at this f of x equals x squared, so my vertex is right here at 0, 0. And so I'm just drawing a regular parabola. Okay, so here's my parabola. And if I have that this is f of x equals x squared. So let's look at if we had f of x plus x squared plus 2. So what that's telling me is that the absolute value of c, so the absolute value of 2 units up, so I'm going up to positive 2 units. So every single one of these points is going to be translated up 2 units. So my vertex is going to go up 2 units. And then all my other points will then follow suit. So they're all going to go up 2 units. And then my new parabola is right here in that blue. So that's my f of x equals x squared plus 2. Then our second line says that if c is less than 0, the graph of f of x squared is translated c units down. So let's draw our f of x squared again. So my vertex is at 0, 0. So I have my parabola of f of x equals x squared. So let's say we're going to look at the parabola that is f of x equals x squared minus 2. So in this case, I have the absolute value of negative 2, so that's 2. And since c is less than 0, I'm going to go down 2. So all my points then would be moving down 2. So I'm just going to move all of my points to go down 2. And they're still in line, and then I would connect those points. So all I did was I translated the graph up and down. I did a vertical translation. A dilation makes the graph narrower or wider than the original graph. So right away I'm just going to go ahead and draw on both of my coordinate planes the graph of f of x equals x squared. So here I have my graphs f of x equals x squared. So the graph of g of x equals a times x squared is the graph of f of x squared, and it's either stretched or it's compressed vertically. So I'm either making it really wide or I'm making it really narrow. So if a is greater than 1, the absolute value of a is greater than 1, then it'll be stretched vertically. So let's take a look at an example. So if I have that g of x equaled 3x squared, then what happens is, since I have that absolute value of 3, which is greater than 1, I'm going to actually have a wider parabola. So this is going to be all stretched 3 points. So even just from those first 2 points, you can tell that my parabola, I'm not going to draw it all the way out, is going to be stretched really wide. So then if a, though, is between 0 and 1, then that means that my g of x is going to be compressed, so it's going to get really narrow. So let's say that I had something like g of x equaled 1/2 x squared. So that means I'd be moving all of my pieces in by a half. And so you can tell that if I was to draw all those points out, that it becomes very narrow. So a dilation either makes it really wide or really narrow. A reflection flips a figure across a line. And if you remember that a reflection is just like if we were looking in a mirror. And with a reflection, we're either going to go over our x-axis, our y-axis, or we can go over any different line. So the graph of negative f of x is the reflection of the graph of f of x equals x squared across the x-axis. So let's draw a picture just to demonstrate this first part. So if this line represents my f of x, then this line over here, and I'm actually going to want to make that, I'm going to make that in red instead, just so that we have something different, represents negative f of x. So I flipped that over across that x-axis. So then the graph of f of negative x is the reflection of the graph of f of x squared across the y-axis. So here we have that this function represents here, and f of x represents that line, and then our red represents this line.